Good afternoon. Thank you for the introduction. Normally, I work in the development team of Line blockchain. I work as a programmer or researcher, and I also conduct development of VM-related smart contract. About a year ago, I did a presentation on Line blockchain. The photo on the slide is from the archive in YouTube. Since the photo is from the video, you see my face in live and the photo from YouTube. So as the slide indicates, I spoke about WASM, WebAssembly, which is the smart contract which has a very good affinity with the smart contract of blockchain. So we are developing a blockchain that would also work as a smart contract of WASM. And the features of WASM is we're working to try to improve the affinity with the smart contract. So here, API usable, the features of WebAssembly is being explained. Today, I'd like to speak about how very useful these features were when we developed the dynamic link function. In a nutshell, it is very easy to link with the other modules of WebAssembly. It can also be applied to the link among the smart contracts. Through this presentation, the possibility of the technology called WebAssembly and the smart contract function of the Line blockchain will be explained. So if I have tried to summarize some of the topics that you may be interested in. The first topic is the interaction of the contract, the dynamic link that Line developed. This function implements the good features of WASM. In this session, this function is going to be compared to Ethereum and COSM WASM, which is the traditional chain of smart contract. Then I'd like to speak about DAO attack and re-entrancy. The interaction function of smart contract has a very, very deep connection with this incident called the DAO attack, very famous Ethereum incident. The damage was about 5.6 billion yen, and it caused hard fork for rollback. This was the DAO attack. You may have heard about DAO attack on social media, but you may not know exactly what it was. So by listening to this presentation, you'll be able to understand the cause of DAO attack, which was the vulnerability called re-entrancy. COSM WASM and Line blockchain has countermeasures against re-entrancy, so I'd like to present that as well. Also in this session, I will also give examples of a contract that utilizes NFT for smart contract interaction. You may have heard about NFT, but you may not know how it is handled within chain or contract. So I'd like you to understand how to implement NFT contract. The agenda for this session consists of the following. The main topic is the dynamic link, but before that, as a prerequisite, I'd like to talk about the interaction of smart contract and the interaction of smart contract. Next, the important feature of interaction is the prevention of re-entrancy and interface detection. Then I will speak about Ethereum and COSM WASM, which is the traditional method, and the interaction of the contract, and also I will explain about the dynamic link of link. First, the premise. First on blockchain. Simply stated, blockchain is the list of records, and it is the column of those blocks. So the tolerance against falsification, distributed application are also their features, but in this session I will only speak about the fact that it is the list of records. Blockchain was originally initiated as a system for currency transfer, but many other information can be recorded. For example, November 13th was rain in Tokyo. That kind of information can be recorded. Also, contracts and programs can be stored, such as if it rains on November 30th in Tokyo, Alice will pay 42 lines to Bob. And this is the type of contract that will be recorded. So these types of contracts or automatically processed programs can be recorded. The program that is executed and stored in the chain is run by the technology called smart contract. Smart contract is stored in the blocks, and the users can execute this code, and it is done by VM provided by the chain. And the execution and the results will be recorded in the chain. Many of the chains are utilized for the contract as well as for transfer, etc. So by adding a new logic to the chain in the smart contract, you can augment the functions. For example, if it rains, Alice will pay Bob. This kind of contract based on weather can be stored as well, can be recorded as well. Next, how does this contract actually work? When the contract is called by the user or other contracts, a VM to execute the code is called, and the code will access the storage. In most cases, the first job of code is to read the input and to dispatch that to the appropriate function. Let's look at actual example and to see how the role of the code is in the smart contract. We will use an avatar image, and we'll talk about a license shop to sell the authority, to sell that avatar. So the storage is the place where the information on the person with the authority and the code are stored. So if it's an avatar license shop, avatar's license and the person with the license combined will be stored in the storage. In other words, this is the person who can use this avatar is going to be stored in the blockchain. In the code, the user can inquire about the information and can rewrite that information. For example, list owned Bob. This is an inquiry. So the list owned will return a bar. Also, owner of bar. This is the inquiry. Then the return will be Bob.
And the users would call these and get the license-related information. Let's think about other functions necessary for the license shop. So setting the license, for example, logic called buy, only when there is a money transfer, the caller will become the license owner. So you can give such condition. When food is on sale, and when Alice calls buy with the money transfer, the owner of the food will be Alice. In increasing the liquidity of the avatar generated and make it popular, you can also make it possible to transfer license. So this function, transfer from Alice, Bob, Foo, when you implement it like that, only when Alice is called, Foo's owner will be rewritten to Bob. So users using these functions communicate to the contract, and based on the code, contract can change the content of the storage. And actually, this liquid, in managing the specific goods with liquidity, the contract is widely utilized, and this concept is called NFT. Now, in the case of the avatar shop, this is also a NFT contract. Even if you know NFT contract, maybe you did not have a clear image of the implementation of the contract, but now probably you have the good image. Now, let me talk about the main topic, which is the interaction among the contracts, giving you some examples. So in the avatar license shop, the contract sells and manages the licenses. And let's say that there are several of them. Various NFTs are sold and exchanged in the various contracts. And managing which license that you have for which shop, and if you want to sell those, it would require certain work. In response to those demands, managing the license that you hold and creating list and do the consignment sales. If there is a contract like that in the chain, it would be convenient. So in many chains, we'll call those contracts, and this type of function is provided to the developers. So here is the agent, which is an example of the contract. So at the top, from the various license shop, agents would collect the information and return the list of the licenses to the user. So calling the list owned by of each shop, and you can aggregate that information to implement this. At the bottom, there is a function of consignment sales. So calling the transfer from of each shop, you can implement this. So in this way, calling the function of the shop, you can create a contract, and this makes chain more convenient. So this is made possible with the interaction among the contracts. Now, let's look at the important features of the smart contract interaction. So there are those functions are supported in the various chains. By knowing those characteristics, when you develop the smart contract, or when you are thinking about the deployment of the smart contract to the different chains, you can use this as a reference. So as I said at the beginning, say that the DAO attack uses the re-entrancy vulnerability, and what kind of countermeasures are there? As a chain, blocking the re-entrancy is the good characteristic. One of the reasons behind this re-entrancy vulnerability is the insufficient lock of storage. Code execution has the right access over storage, and other execution can do the read-write. And when that's possible, there is a problem. The name re-entrancy comes from the attack method of this vulnerability. So let's look at this attack methodology using the slide. On the left, we are showing you the agent contract that I talked about. Agent has the one link, which is the sale of the license by Mallory, and also the 99 link. So total 100. So the information about the one link of Mallory can receive one link in the storage is stored. And from Mallory, agent calls pay to Mallory, and it checks with the storage, and when there is information, Mallory can receive one link. The one link is paid to Mallory, and this information will be deleted from the storage, and so that the Mallory cannot make additional withdrawal. Now this contract appears to be correct, but if there is a hook by Mallory, then it would lead to the vulnerability. And actually, with Ethereum, this type of hook can be made. So when there is a payment to you, once again, you can call pay to Mallory. So that type of hook is something that I like to show you. So using the hook, Mallory says that pay to Mallory, and before calling that, agent can call say that the Mallory can receive one link before the deletion. So it's possible that the payment demand will be made before the deletion. So here, the pay and call will loop So until the balance of 100 link is gone, this will continue. Maruti has the right to only withdraw 1 link, but now it is possible to get 99 link. So the DAO attack, in this case, the attacker should have withdrawn more Ethereum. So re-entrancy is not a vulnerability, but it enables the deployment of the vulnerable contract. So if the chain has the function to block the re-entrancy, that is a good characteristic. So next, I'd like to talk about interface validation and detection. So here, which interface is held by the contract is made public. And also there is a function to check that from outside. Let's think about agent and license shop. On the chain, when the new license shop is established, the agent wants to work with this new license shop. And in the actual chain, many NFT contracts are deployed. So if we can create such contract, it would be convenient. So when the agent thinks that the agent wants to work with a many license shop, it's convenient if there is a common coding method. So here, there is a license shop interface, which is common to 2 contracts. So in response to such a demand in the community, implementing this license shop interface of the license shop is unified. So that means that the definition of the license shop is when the contract implements the license shop interface. And the interface validation and detection actually checks whether interface is implemented. So here, the agent is checking whether the avatar shop is license shop. When you do the contract interaction with this function, more efficiently, you can collaborate among the contract. So now let's look at the interaction function of the contract with blockchain. What we are looking at is the Ethereum's external core, which is most often utilized. Also, the CosmWasm sub-message and reply, which is forked from the Lime blockchain. So in this chapter, I'd like to talk about those 2 mechanisms and 2 characteristics that I talk about earlier and compare them. So before the comparison, let's briefly review the flow of when the contract is called. The contract is a combination of the storage and code. So
when the contract is called, the storage is accessed to call the VM, and the code will receive the input, and the entry point is executed from the path of input of the entry point and the dispatch. First, in Ethereum and CosmWasm, there is a difference between the entry point of the contracts. The contract of Ethereum internally has only 1 entry point, and there is a input binary that is parsed, and the function that is called in that binary is dispatched. The access to the storage from the code is managed by the VM. On the other hand, CosmWasm has multiple entry points, and each has a different role. The basic function is the execute and query. Execute is a read-write authority to storage. Query is a read authority, and it only has that function in the entry point. Other entry points has their own roles. Instantiate and migrate will not be explained in detail here, but reply is a function for contract interaction, and it will be explained in the sub-messages reply. Next, the contract interaction from the developer side will be explained. In this diagram, these descriptions are rather simplified. External call of Ethereum, as is indicated in the left diagram, will call out the function of the external library. From this call, the contract interaction will be generated. To the storage that is called out, the read function or the read-write function can be called out with a similar interface, and the access authority to the storage is controlled by the context of the call from the VM, and that causes various errors. Sometimes there are additional functions. In COSM-WASM, the interaction of read authority and the read-write authority are clearly distinguished. The entry point to read, which is the query, like Ethereum, is done by calling out the external library. The right-hand side query is what this does. On the other hand, read-write authority is called out by the execute, which is the submessages and return. The arrow that starts with return on the query side shows that flow. If you want to call out other contracts from the execute, then you have to create a command of submessages, and this is returned in the execute as a submessage. Based on the chain function, the contract of the submessage, designated submessage, will be called out. The contract that is called out will be returned to the reply side, and the process will be returned to the entry point. So the first thing is that the execute of the return side will be completed, and then the contract call from the return is done, and then finally the callback reply will be executed. It may seem like a complicated flow, but this will be useful for the prevention of reentrancy. Let me now speak about the relationship with reentrancy. Reentrancy is a code that is simultaneously executed with the read-write authority. That was a vulnerability. In Ethereum, external call will call contract 1, contract 2, and both of them are being called together. So if you call 1 from 2, then the reentrancy becomes possible. So the same kind of flow can be done with COSM-WASM. In COSM-WASM, when you call other contracts, you have to complete your execution and then call again as a submessage. In this diagram, it shows that no two read and write authorities simultaneously have that authority. So this will prevent reentrancy. Finally, interface validation and detection function. Both chains does not have a function as a chain in interface validation, but in Ethereum, RFC of Ethereum version, that is the ERC, is the standard protocol for this function. ERC 165 will make a self-report to the record of the interface that you execute. ERC 820 has related information aggregated inside the interface that serves like a database of the contract. And each contract will make sure that your interface is being registered. On the other hand, COSM-WASM does not have a validation detection function of the interface. Let me summarize. First, the external call of Ethereum. First, for reentrancy tolerance, it does not have a very good function. Ethereum itself is able to deploy a contract that is vulnerable to reentrancy, which means the contract needs to do its own locking and to defend itself. On the other hand, there is an external tool that does a security check for the contract code, but the chain itself does not have a good function or feature. Next, interface detection. It has both pros and cons. The good part about this is that ERC in Ethereum is very standard, so you can use interface detection naturally. The bad part is that the chain itself does not support the function, so the information may not be accurate since the interface information of ERC is all based on self-reporting. Finally, in development, as was introduced, the external library call is enabled. So you can utilize your experience from programming the languages. So it has a good development experience, but it was like a pioneer contract, so it does not provide sufficient VM functionality. Next on COSM-WASM.
So first of all, the re-entrancy is prevented by the chain itself, so there is no re-entrancy attack, and this is a good feature. Next is interface detection. Concerning that, currently it is not supported. Finally, about the development, there are good things and bad things. Good things include that at each entry point, there is a minimum level of the privilege given to the storage. So Cosmos SDK, it is possible to have an interaction with other modules. Bad thing is that as we started the development, this is a kind of a peculiar and a complex method. That is, you have to get used to sub-message and reply. As a whole, sub-messages and reply, those are unique methods, and with them, it is possible to work with other modules of the chain and also controls the stress, the access, and prevents the re-entrancy. But it is special and complex, so you have to really get used to this way in the development. So by utilizing the advantages of the WASM, we wanted to take advantage of the good development experience of the Ethereum and also have the support for the interface detection. So we extended the COSM-WASM to develop the dynamic link. So now I'd like to talk about the main topic of the dynamic link and what is the method and how do we utilize the advantages of WASM. Now, key idea of the dynamic link is the WASM's import and export is converted to the virtual VM's API and entry point and mediates the chain system. And the import-export is actually for the dynamic library, and the VM actually connects them. In dynamic link, we extended this. So the function exported from the contract is imported from other contracts, and it is made possible to call this for the interaction. So actual flow of call is as follows. On the left, we have a caller side, import callee.bar. This is the code, and for VM, this is to prepare for the external API so that the chain can be called. So when the imported callee.var function is called, that would be the call to call API provided by chain. So chain, when the API is called, as you see on the right-hand side, the callee side of VM will be started up, and the entry point will be communicated. And entry point is made up of export bar in the code. So that in dynamic link, import and export of the WASM will be converted to API of a VM and entry point, and mediates this with the chain system. So what kind of characteristics is realized by the dynamic link? Major feature is that can be realized as a chain's function, the interface validation is realized as a change function. And inside the WASM code, a chain actually checks the export, and it can be done with the reading the header in the WASM, and so it's simple, and you don't need to use the public function of the interface that was necessary for the Ethereum. And we can also prevent the implementation error. Now, next about the reentrancy, checking the core stack, we can block the execution of this twice. This is an ad hoc limitation, but the chain prevents the reentrancy, and this is a good feature as a result. In dynamic link, we realize the desirable characteristic of the contract interaction. Let me summarize. In a dynamic link, the reentrancy attack is prevented by the chain, and it's a good feature. But the method is ad hoc, so this needs to be improved. Also, the interface validation takes advantage of the characteristic of a WASM and is realized as chain's function using the WASM header information. So it's not influenced by the contract implementation. It is always right information, and it can be utilized. Contract developer does not need to implement the interface information function. So this is a unique characteristic that conventional chains do not have. Finally, as for the use, the methodology to use it, it's possible to use something similar to the external library core. So it's very simple as Ethereum, and it's a good feature. So dynamic link prevents reentrancy and takes advantage of that one, the merit of the Ethereum. So simple calling method is possible. And with the interface validation, it utilizes advantages of the WASM and can generate the unique characteristics. So summary is that I talked about the dynamic link, which is the smart contract interaction method. So function for the smart contract interaction was explained. And we implemented the dynamic link as an extension of the COSM WASM and maintains the good development experience of the external core of Ethereum. And just like COSM WASM, it blocks the reentrancy by chain itself. And using the WASM characteristics, we can have the interface validation with a chain itself. So it's a unique feature. And we can show the potential of the smart contract of WASM. So it's a very interesting function. And lastly, the Line blockchain develops the many chain functions. And of course, the dynamic link is developed as part of the OSS. And this time, when I presented the dynamic link, actually has a disadvantage that the method of prevention of the reentrancy is kind of ad hoc, and there are other areas that need to be improved. We are happy that you cooperated with us, and just looking at it or trying them will give us a lot of power. So please check our Line organization GitHub. And with that, I'd like to end my presentation on the dynamic link using WASM. So smart contract WASM and Line blockchain smart contract, if you're interested in this, smart contract development tutorial archive offers the actual experience. And last year, I talked about the WebAssembly, and if you look into that, you will be able to feel the potential of the WASM with the smart contract. And with that, I'd like to end my presentation, and thank you for your attention.
Thank you very much, Mr. Takase. We will have a plus talk. The questioner can ask about the questions that they want to deep dive We can also accept questions from you. So please click the question mark at the bottom, right-hand bottom of your screen and send the questions by chat. Mr. Toshimasa is going to be asking the questions. Thank you very much for your presentation. Please have a glass of water and take a little rest. Mr. Nasu, could you please introduce yourself? From Line Blockchain Development Team, my name is Nasu. Actually, we work together. So, last year, he made a presentation about the cosmosm at Line. Maybe you didn't really speak about the cosmosm of Line. Would you like to talk about that? Cosmos SDK is something that Line uses to develop the blockchain. That is the background. And based on that premise, we had several candidates. So the question was, how are we going to realize a smart contract? So the candidate was Ethermint. It's Ethereum VM to realize this on Cosmosm. So we selected Cosmosm. And the biggest reason is because Cosmosm is a web assembly, because in the smart contract area, I think a lot of potential is in that technology. So we can deploy the web assembly here. That was the major reason. I see. Okay. So Cosmosm is open source. And then Line, I think, forked it. Why did you fork it to implement a dynamic link? Well, dynamic link, it has a very large function. So until we can launch it, of course, it requires a lot of manpower. So we decided to create this one big function so that we can make proposals to others. So first we created the dynamic link in the fork. I see. So this is contributing to open source? That is wonderful. Well, yes. Line would like to contribute to open source, and our team would like to make contributions to open source. So I hope that dynamic link can be improved so that we can propose this function. Yes, that's something to look forward to. Now, Cosmosm reply and sub-messaging function. Well, we created a similar function called the dynamic link. So if you use the Line blockchain, that means there are two functions. How do you distinguish between the two? What do you recommend? Well, I think you can use it in different areas. Dynamic link is the interaction between contracts. So that is one of the reasons that we developed the dynamic link. And as I explained in the presentation, Cosmosm, it's a Cosmos. It's something to create the Cosmos chain. There are various modules. And of course, Cosmosm is one of the modules. But the other modules, you can also interact with other modules. So it will be different from calling out a contract. So the Cosmos traditional calling function was utilized. So as to distinguish between the two, if you want to communicate with other modules, then you have to use the sub-messaging. However, if it's a communication with between the contracts, interaction among the contracts, then the dynamic link would be most ideal.
So from the user's perspective, there are more options, and this can be implemented well if you can use it differently. And you are still in the process of development. You mentioned that the dynamic link branch. So if you use that, can you actually use it now? Well, right now, in parallel, there's a Takahashi-san's session. One of our colleagues is presenting right now, and in that session, the Line blockchain, Cosmosm contract development, and catching up or tutorial session is being given. So there, using dynamic link, this person is talking about the tutorial, so it could be archived. So if you look at that, so we are already showing that. Yes. Well, this time, COSM was used, and you said that there could be WASM. So WASM VM. So this time it's COSM and EVM. Anything else? The VM engine that you are thinking about? Well, Polkadot, the ink. It's a kind of a framework. Uses the WASM as a smart contract, so VM and surrounding framework. This is something being developed, and we know that. So this time I didn't touch upon it. So from the last, you can generate so this is like the COSM WASM. So that's been developed. So it has unique features, so I'm watching that with interest. So re-entrancy issue, how do they solve that? Well, about re-entrancy, I did check on ink, but it is possible that they are not yet able to block it. But it says that they are looking at it, and they will be solving that in the future. So I look forward to that. So it's open source, so it's visible, and you can see that each other. Yes, we developed this in open source. So I'm hoping that you utilize it and compare them to see which one is easy to use and give us a feedback. That would be helpful. One final question. The OSS and the Cosmosm is a platform, or you also create engine, so showing many people and having the contribution, and you also contribute to other projects. So Takase-san, you yourself, do you think that it's attractive, or anything that you keep in mind when you do this? Well, 2020, I graduated school and I joined the company. So before that, the programming language was the area that I did the research on. So creating something using this, that foundation is something that I'm very interested in. So not creating the smart contract, but the VM that uses the smart contract, and developing something like that is I find very enjoyable. So if you develop a framework like this, the developer can intuitively create something better. So that's how I want to do the development, and that's something that I always liked. So that's something that I keep in mind all the time. And as I exchange views with other engineers and developers, I enjoy making development. So I can feel that you are enjoying it, and you also can work with outside people, and it's great that you are enjoying this. So with that, I'd like to end the Q&A. Thank you very much.